So for today, we'll be discussing Module 15, Lesson 1, and it's about solutions to right triangles. So supposing we have this right triangle, and we name this right triangle as right triangle ABC. Remember that the right angle is always angle C, but the acute angles can be named angle A or angle B. So I'll just name this as angle A and this as angle B. The side opposite angle C is side C, denoted by a small letter. The side opposite angle B is denoted by small b, and the side opposite angle A is denoted as small a. So in order for a right triangle to be called solved right triangle, all the three sides should be known. At the same time, all the three angles should be known. So a solved triangle, again, has three sides known and three angles known. Now, there will be cases wherein a given right triangle has missing components. So let's say we have the example, solve the following right triangles where C is equal to 90 degrees. So let's have the right triangle whose side A is equal to 4, side B is equal to 3. So in order for us to solve this case, or so this right triangle, first we need to draw the right triangle. Let's first solve the right triangle. Let's draw it first. So we have here angle C. This is angle A. This is angle B. Side A is equal to 4 and side B is equal to 6. So what are missing are sides C, angle A, and angle B. So how do we solve for each? What we can do here is first, we use the given values. We're given two sides, therefore we can find one side using the Pythagorean theorem. So the first thing that we can find here is side C, and we use the Pythagorean theorem. Pythagorean theorem is C squared is equal to A squared plus B squared. Hence, if we want to solve for C, C is the square root of A squared plus B squared. Substituting, we will have 4 squared, square root of 4 squared plus 3 squared. And that would give us 16 plus 9, the square root of 16 plus 9, which is the square root of 25. Therefore, C is equal to 5. So we already know the value of C. So I will just write it here. C is equal to 5. Next, we need to solve for the angles because angle A and angle B are not given. So we can solve a given angle given the sides by using a trigonometric function. In this case, the side given is A and B. I know that we've already solved for C, but as much as possible, we do not use the sides or the angles that we solve in our substitution. It's best if we still use what is given so that we will not commit any additional error. So let's use a trigonometric function. Again, when you're looking for an angle, two sides are given. What you can use is a trigonometric function. And looking at A and B, what are A and B in relation to angle A? Side A is opposite angle A, and side B is an adjacent side of A. Therefore, the trigonometric function that we can use to find A is tangent. So we will have tangent A is equal to 4 over 3. To find the angle, we need to find the inverse of the value. So it's like dividing the whole equation by tangent. However, if we express it in negative exponent, it will become negative 1. So A is equal to inverse tangent 4 over 3. So where will you now solve this one? You can use your scientific calculator to solve for the value of the inverse tangent 4 over 3. So using your calculator, let us open an online calculator. So I'm using the Desmos scientific calculator, and when you press the function button in the Desmos calculator, you will see here the inverse tangent button. Okay, so if we click that inverse tangent and then we go back and then write 4 over 3, so that's a fraction form. I will click here the A over B button so that I can write a fraction. So 4 over 3. And then again, I will close that using a parenthesis. Then the answer is 53.30. Therefore, the value of angle A is again 53.30 degrees. So we already have a value for A, and I will put it here. It would be easy for us if we just use the concept of A plus B equals to 90 degrees to get the other acute angle. However, as I mentioned a while ago, if we use that, there may be an additional error for us because what if your answer to angle A is incorrect? Automatic, if we will use angle A in solving for angle B, your answer may also be incorrect. Therefore, we still use or stick with the given information to solve for angle B. And in this case, since the two given information are sides, we still use a trigonometric function. What trigonometric function can we use using B and A in order to find angle B? So as you can see, side B is opposite angle B and side A is adjacent to angle B. And if we have opposite over adjacent, that means we will be using the tangent function. So we will have tangent B is equal to 3 over 4. Again, since we're looking for the angle, we will find the inverse tangent of 3 over 4. We then again use our calculator. We click inverse function, inverse tangent rather, and then the fraction button, and then write 3/4. And the answer here is 36.86. Now, if you add 36.86 and 53.13, your answer must be close to 90 degrees. The answer here is actually 89.99, and that's very close already to 90. So that means our answer is correct because the sum of the sides of an acute angle of the acute angles of a right triangle is equal to 90 degrees. So that is one example that you can on how you can solve a triangle, a right triangle. So again, a right triangle can be solved, can be called solved if the three sides and the three angles are known. Let's have another example. Let's have a right triangle whose given information are A is 30 degrees and the side B is 15 units. So again, the first thing to do is to illustrate the triangle, the right triangle, so as to visualize what are the different information. So we have C here, which is 90 degrees. A is given and it's 30 degrees. This is B. Opposite to B is side B, which is 15. We do not have side A and we do not have side C. So in this case, we cannot find one side because we cannot use the Pythagorean theorem to find the other side because only one side is given. But we can use a trigonometric function to find a certain side. So for example, we want to solve for angle A. Then we can use a trigonometric function using angle A 30 degrees and B 15. So side A is opposite angle A, while side B is adjacent angle A. So I can say the function tangent, so tangent 30 degrees is equal to the opposite, which is A over 15. From here, we can now solve the equation by finding the unknown value, which is A. We use cross multiplication. So we will have A is equal to 15 tangent 30 degrees. And again, we use our calculator, our online calculator, and we input this information. So we have 15 times tangent 30. And the answer is 8.66. So we write here A is equal to 8.66. So this is now our value for A. So you might say, oh, we already have two sides. I can already use the Pythagorean theorem. So it's also possible to use the Pythagorean theorem. But again, let us go back to recalling that if, for example, the value for A that you got is incorrect, automatically the value of C will be incorrect if you use A as your substitute value. Hence, we still use angle A and angle B, angle A and side B as part of solving for C. So let us now solve for C. What trigonometric function can we use in order to solve C? B is the adjacent side of A, while C is the hypotenuse. And we have the adjacent and the hypotenuse. The function there is cosine. So cosine 30 degrees is equal to the adjacent side, which is 15 over C. So again, we cross multiply. We always add 1 to the whole number. because if there's no written denominator, it's automatically 1. So we will have 15 is equal to C times cosine 30 degrees. And we do not need cosine 30 degrees here because we only need C to be isolated in one side. So we divide by cosine 30 degrees. Hence, in order to solve for C, it is 15 divided by cosine 30 degrees. So we go back to our calculator and key in 15 divided by cosine 30. And it gives us an answer of 17.32. So our hypotenuse measures 17.32. So we only have one quantity left unknown, which is B. And as we mentioned, the sum of the acute angles of a right triangle is 90 degrees. So if the first acute angle is 30 degrees, in order for us to find angle B, we will use the principle A plus B is equal to 90 degrees. Hence, B is equal to 90 degrees minus A, and then B is 90 degrees minus 30, and that would give us 60 degrees. Now we can see that the triangle is solved. So the value of the sides are 8.66, 15, and 17.32, while the values of the angles are 90, 30, and 60.